in the design principle, we have another kind of principle, we call it encapsulation. The encapsulation, it is a process of binding both attributes and methods together within a class. So the attribute means the data member, and methods here, this is the method or functions, and we want to bind them together in a class. Through the encapsulation, the internal details of a class can be hidden from outside. It means we do not need to share our data. Yes. For example, some of the case, let's say you have the bank account. Of course, this is, we call it 개인정보, the private numbers, okay, the private data. We cannot share the data, so it should be hidden. That's why we can use the encapsulation for this purpose. The class methods, it provides user interface to access the class services. And there are some concepts. For the access, we can set up as a default, or we can set up as a public, private, or protected. We can create a class or interface. So just an example. Whenever you see the class, and if you look at the class with the underbar, like this one, this is private. So in Python, they already define that if you use a very common variable like this one, title, for example, so this is a public data. And if you use underbar, this will be included as a private data. When it is a private data, then it is only be accessible in this class. So from other class, you cannot access it. From other class, you cannot call. Okay. So one should not call this method from outside of the class. So you can see here, the data here is private because we have underbar, and we have also the method with underbar. So this is also a private method. When we want to access the public data, it is available, okay, with just calling the data. For example, I want to call the title. Okay. Let's say, yeah, I have my diary is the diary. It is the object of the diary class, and then let's make a diary title. Don't read this. And then I have another new entry. For example, I have another diary. I have another journal. Yeah, the title is "It Was a Good Day." When I have the diary called, so what is the new title? So the new title will be the title that you just entered. If you want to access the data and the method, you can try to press the tab. You can access it, but yeah, it is hidden. Okay, for example, I have this class diary. And then I want to access the data member. The data member in this case is the title. Okay. You can see the data. We have the first title is "Don't Read This," and then I have actually the new add entry, but it does not appear. Now you can try. This is the object, my diary, and then yes. If you look at this one, only add entry and title. Where is the other data type, which is underbar entries? It is not available, or we call this is hidden. This is hidden because you use the underbar, so you cannot access it. Let's say if you have another self name equals to, for example, half, like this one. Okay. If I write this, okay, and if I do this one, but then you will see add entry, name, and title. So if there is no underbar, Python will know that this is a public. If you use underbar like this one, then it is a private. This is a private method. Then if it is a private method, and if it is a private, this is a private method and this is a private data. So how can we access it? Those two can be accessed only inside this class. Well, that's why whenever you create an algorithm, okay, you can hide some of the details. Okay. Let's say I do not want to share this one. I do not want to share this one. So I will create a new method, check entry, and then this check entry can access the method that you have, this one, and this hidden method can access the hidden data. By using this one, you can check what is the method, and then you can get the last data that you just input. If you do not use this one, so you cannot get the last data that you input. You just get the data that you input at the first part. Okay. So this is one of the example of the encapsulation. So we have the new method. This new method is accessible, and this new method will access the hidden method, and this hidden method will access the hidden method. So you can access the hidden method and the hidden data inside the class itself. You cannot access from other class. You cannot access from the object. Okay. When you use the function, the object range in Python, you may have the statement for loop for I in range 0 until 10, for example. Okay. So the function range, actually, it is a kind of iterators or iteration. It is an important concept in the design of data structures. And in the iterator, there is a collection of a key behavior. We call it the underbar next. The underbar next, it returns the next element of the collection, if any. Or it raises the stop iteration exception. It is to indicate that there are no further elements. So if we have a kind of array or list, 1, 5, 3, 4, for example, like this. So now I'm accessing this one. The iterator will check, is there any next element? Yes, then it will return the next element. Is there any next element? Yes, okay, we will return the next element. Is there any next element? Yes, then we will return it. Is there any next element? No, then it will raise the stop iteration. When we use the range, actually it is a class. So the class name is range, and then it contains three kind of arguments: start, stop, and step. The start means what is the index that you want as the starting point. The stop is known. It means when you don't divide any numbers, then it will be empty. And then step equals to 1 means this is the default. If you do not divide any numbers, then Python will know that there will be step 1. So if the step 0, there will be errors. If the stop is known, then it means the starting point is 0 and the stopping point will be equal to the start. So that's why if you look at the Python file, what the result if you have the for I in range 5? What is the result? You will see 0, 1, 2, 3, 4. Is it right? Why this one happens? Because this number 5, and it will check start equals to 5, stop is known, and step is 1. Now if we check that one, because the stop, there is no stop if we use the range equals to 5, because there is no stopping. So it is only a start number. Then, because the stop is known, the start will be from 0, and the stop will be the start. And then we will check the length. The length means the maximum of 0 or this one. The stop minus start plus step minus 1 dash slash step. Yes, the slash means I want to get the integer number. Okay. So the starting point will be the start, and the step will be the step. If you want to get how many numbers do I have in the range, then you can use the length. And then if you want to get the items, so for example, I want to know what is the item in the index K. So I can define with the get item. Okay, so this is from the class names. So you can take a look. I also give you the code. So you can upload the range.py here, and you can open it. So this is the class range that usually we use for the loop. Okay. So you can see how we usually use the range, and this is the basic idea for the iteration. For the final project, I hope that you will create the Python code from scratch like this one. So some of the algorithms maybe you can get from the Python library, but I want you to minimize the usage of the library. So I want you to write the code from scratch. Okay, so later we can discuss about the algorithms. What are the algorithms that you can utilize with the libraries? What are the algorithms that you need to write from the scratch? The last part that I want to explain is examples. So in Python, there is a kind of built-in function about exception. This is one example that is good to explain about inheritance. the exception, we have the base exception. In Python, the base exception means whenever you have an error, then you can show the message, the error message. But the type of the message or the type of the exception can be anything. For example, maybe the keyboard interrupt exception, or the common exception, or the system exit exception. And for the exception, there can be different kind of errors, whether it is a value error, or lookup errors, or arithmetic errors. The arithmetic errors means this is something related with the arithmetic. Let's say 5 divided by 0. Okay, so this is arithmetic errors. That's why one of the class is zero division error. For the value error means if you include some values on the string object, this is value error. Lookup error, we have the index error. So for example, you have the list, okay, 1, 2, 3. So we will have 3 elements. So this is index 0, this is index 1, this is index 2. But you want to access index 3. Of course, this is error. So this is a part of the index error. The key error. So you already learned about dictionary last week. In the dictionary, we have the key. If the key does not exist in the dictionary, then it will show the key errors. So actually, there are still a lot of exception, but I think this is the most common errors that you can use in Python. You learned last week also, we can use try except to catch the error. Now I will like to use this try except, and I'm using the value error means if the input is not as the expected value, show the value error. In this case, can you guess why it is error? We have try. X equals to integer hello. What is the error? Hello is characters. Okay, so it is not possible to convert this string into integer. Then we will show the value error. If the value error happens, then we can print value error happens. If it is not about the value error, then let's go to the exception and let's print some other error happen. Then in this case, the value error happen. How to fix this error? As you know, actually, we can use integer when the string contain of number. Okay. So if the string, inside the strings are numbers, it is possible. But if the strings include all characters, it will be errors. So using the try except, we can get what are the errors in this case. The other kind of examples when we do the exception is we can have a self-defined error. So you can define your error because whenever you do with the algorithm, your algorithm should catch the error by itself. Now, for example, I have a new class and this class is a balance error. And this balance error, what does it mean? This is inheritance. So the balance error will in the exception, and for all the exception, it will be included in the balance error class that I define. Once the balance error happen, pass. Okay. Now I have one function, balance and amount. If the amount is higher than the balance, let's raise the error. So the error is not enough balance. If this one is false, then return this. So I will try. I put the balance lower than the amount. So if the 100 is the balance and 200 is the amount. 200 is higher than the balance. 200 is higher than 100. Yes. Then raise this error. Not enough balance. Okay, not enough balance. So we can try with others like this one. Let's make it different. 200 and 100. Nothing happens because you just return this one. So I can make it like print. Then it returns the subtraction between the balance and the amount. Okay. So the last example, it is the example from the book. And this shows inheritance about the numerical progression. Numeric progression means it is a sequence of numbers where each number depends on one or more of the previous numbers. For example, the arithmetic progression. The arithmetic progression determines the next number by adding a fixed constant to the previous value. So, for example, I have 1, 2, 3, 4, 5. So it means this is the arithmetic progression. Every number is added by 1. So 1, and then if I add by 1, then it becomes 2. And then if I add by 1, it becomes 3. Add by 1, it becomes 4. Add by 1, it becomes 5. The geometric progression determines the next number by multiplication. Okay. So the first is by addition, adding, but the other is by multiplying, multiplication. We want to multiply the previous value with a fixed constant. For example, I want to multiply those numbers with 2. Okay. Then the first number is 1. I multiply with 2. Then 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. And so on. So we call this is the geometric progression. And the last is Fibonacci progression. The Fibonacci means I want to know the next number. It is based on the 2 previous numbers. So 2 is the result from 1 plus 1. 3 is the result of 1 plus 2. 5 is the result of 2 plus 3, and so on. So we have a class, we call it progression. And this is the base class. In the progression, we can split into 3 subclasses. Okay, so this is the subclass, or we call sometimes the child class. We can use the arithmetic progression, we can do the geometric progression, and we can do the Fibonacci progression. Let me show you the class. Okay, so this is the class progression. We want to set the initial or the constructor. So the constructor starts with 0. So the current equals to the start. Advance. So advance means I want to update the current value with a new value. So the simple one is adding by 1. Okay, so this is the default. So I can check what will be the next value. Okay. The next value, as I mentioned to you before, we can do with the iteration. Okay. The iteration means the next. I want to know if the current is known or not. If the current is known, then stop the iteration. If not, then let's put one variable, name is answer, and then put it as the current value. And then go to the next. Self-advance means I'm going to use this advance to go to the next value. And it will return the answer. The iteration means the iterator. And then print progression. So I want to print what is the result from the progression that we have. So we use the join. And then I want to see what is the next value for the j in the range of n, and put of them as a string. Okay. I hope that you already understand this code. Okay, so because you learn in computer programming about the one-line statement for the for loop. So this is the class progression, and now we are looking at the subclass. The subclass means the child class. We have the class arithmetic progression. So this arithmetic progression will inherit from the progression class. This is inherit from progression. The arithmetic progression, we have the constructor. Now the increment means the additional. After we have one number, it will be added 1. The starting, if there is no information, let's start from 0. When we call this one super means I want to call the super class, which is the progression, and then let's construct the object with the starting value. If the start is 0, then let's start with 0. Maybe if we define the starting with another value, yeah, we can have another value. So the increment will be based on the increment value. For the advance, it means I want to update with the next value. The advancement, it will be depending on the number of the increment. If the number of increment is 1, then I will increment 1. If the number of increment is 2, then maybe after I have 1, it will be added by 2. It will be added by 2. It will be added by 2. It will be added by 2, or something like this. If the start number is different, let's say if I'm starting from 5, and then the increment is 2, then it will be 5, and then 7, and then 9, and then 11, and so on. Okay, so it depends on the input for the arithmetic progression. What about the geometric progression? It is the same. It inherits from the progression. Okay, it inherits from the progression. And then the constructor, we have the base. And we have the starting number. Once we have this geometric progression, again, we will do the construction from the superclass. The superclass means the progression class. And then we want to define the base equals to the base that we define here. If the base is 2, then we will multiply its number by 2. When we want to get the next number, so the next number will be the base multiplied with the current number. So if the current number is 1, then we will multiply with 2. Then multiply 1 multiplied by 2, then it is 2. If the current number is 2, we will multiply with 2, then the current number will be 4. If the current number is 4, we will multiply with 2, then the current number will be 8, and so on. If we change this base, into 3, and let's say the starting number, let's say we start from 2, then the starting number will start from 2, and then multiply by 3. Then 2 multiplied by 3 is 6. 3 multiplied by 6 multiplied by 3 is 18. 18 multiplied by 3 is 54, and so on. Okay, so it depends how you define the class. And the last one is the Fibonacci. Okay. So the Fibonacci, as you know, if we have a sequence 1, 1, 2, 3, 5, 8, something like this one. So 2 is the addition of 1 plus 1. 3 is the addition of 1 plus 2. So we need to define what is the first value and what is the second value. Once we know the first and we know the second, then we can define the third. We have the constructor. We call the superclass. The superclass is the progression. And the previous will be the second minus the first. So if we want to get the new value, so the previous and the current will be here. The previous will be the current, and the current will be the previous plus current. So this is the Fibonacci progression based on the progression superclass. Okay, let's see the code. I give you the code as well. You can upload it, the progression class. Okay. So this is the progressions. This is the class progression. Init, advanced, and so on. Okay, this is the class that I already explained before. Okay, let me just copy and paste this one. It is just for the easy showing in the Google Colab. So before you do this one, you need to again import. How to import it? How to import this one? We need to use from. We have the progression, import progression. Is it enough to import only the progression? Let's see. This error. What is this error? The name arithmetic progression is not defined. So we need to call all the class progression arithmetic progression, geometric progression, and Fibonacci progression at the same time. Let me close this one, and then after you get the file name progressions, import progression, arithmetic progression, geometric progression, and Fibonacci progression, then we can run the code. If it is a default progression, then I will just use the progression and print the progression. So I want to print 10 numbers. What is the result? I will show only 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I am using the arithmetic progression. So I want to show with the increment of 5 and show only 10 numbers. So it starts from 0, plus 5, plus 5, plus 5, plus 5 until 10 numbers. Arithmetic progression 5, 2. So the increment is 5. Now the starting number is 2. And I want to get 10 numbers. Then starting from 2, plus 5, plus 5, plus 5, plus 5 until 10 numbers. The geometric progression with the default. If there is no parameter, we use the default, which is the number multiplication with 2. So the default base is just multiply with 2. 1 multiplied by 2, multiply 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 by 2, and so on until 10 numbers. Here, this one is geometric progression with base 3. Then we have multiplication with 3 for 10 numbers. 1 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3, and so on. The Fibonacci, if it is the default, we can have 10 numbers of the Fibonacci. 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. Now let's change the starting value. So if I start with 4 and 6, then the progressing will be the same, but the difference is only starting number. Now 4 and 6 is the starting number. The next will be 10 because 4 plus 6. The next number will be 16 because we know that 6 plus 10 is 16. The next number is 26 because we know that 10 plus 16 is 26, and so on. Okay, so using this idea, we can have the inheritance. So it means we have only one class progression. We can have multiple subclass. And later on, if you work with the algorithms, you can have another new class. You can have another new class about the progression. You can just add the subclass. Okay, you can just add the subclass, another subclass, and everything will inherit from the parent class. Okay, that's all for today. So any questions? Okay, if no question, then from next week, we will start more complicated things. Okay, so please review what you learned from the week 2 and week 3. So next week, we will do something more about the algorithms. So thank you very much for your attendance. We will meet again next week. So,